Hey guys, we're going to go over the most used formula on the SAT. Now, before you decide that I already know this formula, I'm going to skip this, I want you to listen to what I have to say. If you're at the point where you are, or if you get to the point where you know everything that's on there, you understand everything, and you're having trouble in terms of your timing, and you need more minutes to be able to finish the test and finish some of the harder problems, this is a place that you can reduce your time significantly. And that is by understanding all the ways to get through and use this formula effectively and fast. And I'm going to show you some tricks and techniques to get through these kinds of problems even faster than you might otherwise. Okay. I don't always write down how often a formula appears on every SAT, but this formula appears on every SAT. And I do remember that on one SAT in particular, it appeared 9 times, 9 out of 58 questions. That's about 15%, 16%. And that's a lot. That's a lot. So that could really speed up your time if you can recognize how to use the elements of this formula very, very quickly. Sometimes you don't even need to use the whole formula. Okay, so the formula I am talking about is the slope intercept formula, also known as y equals mx plus b. Okay, so looking at y equals mx plus b, well, let's talk about what this means. This is the linear equation, and there are 2 formulas that appear on every SAT. That is ax plus by equals c, or y equals mx plus b. The y and the x in both of these formulas are the same. There is no apparent m or b in this formula, so if you have to convert it, that's what you need to do. You can convert this from y equals mx plus b to this standard formula, or you can convert it to y equals mx plus b. And in doing so, you're not really changing any elements other than making it much more easier to graph on a line. Okay, and I'm going to talk about why as we go forward. I'm not going to do that right now, but I'm going to talk about graphing this as in one of the examples. But I do want to talk about what the elements mean and why this is important. So we use this line to explain things. Okay, so for instance, if I have, let's say that I'm going on a cab ride or an Uber, and I want to know how much it's, if it's going to be better for me to take the whole Uber ride, even though I know it's more expensive, or to get off to maybe go 15 miles in an Uber and then get off and take a bus or a train and go the rest of the way. Okay, real life problems there. So my y represents my total value. Okay, that could also represent the result or the remaining value. The remains, what remains, okay? It's all the same thing. Now, my y-intercept, which is what we call b, my y-intercept, this is what I start with. This is the y that I start with to end up with this y over here. So this is my initial value. Or my starting amount. Okay. So I start with this, and somehow I'm going to do something over here and get over here to this. So my Uber ride, for instance, charges a set amount regardless if I go anywhere. So even if I stay in one place, I'm going to have to pay a minimum amount to Uber. Now, what I pay is going to, the rest of the way in terms of mileage is going to depend on how far I go and the rate. So let's talk about what we have here. We've got our rate, which is the slope. M is the slope, and it is our rate. It is something per something. It's our rate. It is our change, regardless of what X is going to be. Okay, it's going to change by this amount. It's either going to increase, in which terms, in which case M will be positive, or it will decrease, in which case M will be negative. Okay, now, then we have X, and it is our unit of change, or the number of units of change. Okay, so and this varies per situation. It doesn't vary, however, per the equation. So in other words, if I want to go 15 miles, then I'm going to put 15 in for X. If I want to go 18 miles, I put in 18, but it's going to be the same equation. Everything else is the same. The rate doesn't change. What will change, however, will be my final result. Why? Because Y is a variable. So Y is my dependent variable, okay, because it depends on all this other stuff. Now, because M and B are basically constant in this equation, then the determining factor is going to be my independent variable, which is X. Independent because I don't know how many miles I'm going to go, but I am going to go a certain amount of miles. And once I determine that, that will determine Y. Y depends on X. Okay, so hope that makes sense. So for instance, then, if I am going to go, if I'm going to start, now, let me back up for a second. So what I want to know here in this particular case of the Uber is that how much is this going to cost? What is going to be my amount? So Y is going to be how much it's going to cost. Okay. Well, sorry about that. That doesn't look too pretty. Let me fix that a little bit. So I'm just going to rewrite this just so it looks a little better. So Y is going to be my final amount that I'm going to have to pay. And then M is going to be my rate. And in this case, it's going to be dollars per some amount of dollars per mile. Okay. Now my X is going to be how many miles I'm going to go. Okay. And then this is going to be the amount of money, the amount of dollars I'm going to have to pay to start with, regardless of how many miles I'm going. So for those of you chemistry folks, this is called dimensional analysis, which means that I can cross out miles here, and I'm left with dollars times some amount plus dollars equals dollars. Okay, so when you're confused sometimes on the SAT about where to put stuff, think in terms of what do I want to end up with? So how do I arrange things in a way that, for instance, if I want dollars, that means that anything here that has dollars is going to need to be on top. And anything that is some other unit besides dollars is going to have to cross out. It's going to have to be offset. And so I'm going to have one somewhere in the denominator, one in the numerator. But the fact that I have a rate here with miles in the denominator, that tells me where my X is going to go. And that tells me, like, if I have just a bunch of numbers and I'm not sure if it's X or M or what, this tells me where I need to put the stuff. Okay. This tells me. So that's going to give me my final answer there. All right. So anyway, that's how we want to process. This is how we want to think about things. This is how we want to think about the y-intercept, the slope, and the change in the units and y and all this. And this is going to be very important as we move on into the questions. And as I said before, we'll look at graphing linear functions below with one of the examples. So, all right, let's take a look at some examples here. And example number one, and this is a pretty easy one as far as the SAT goes. In a training event, so let's always start with looking at the question itself. And the question itself starts with the word which. Okay, that's a key thing for the SAT math. You want to start with the question. Which of the following represents the remaining distance, D? Oh, so we have D. D equals remaining distance. That's what we're looking for. That's what our answer is going to be. Now it's asking what it represents. So if we look at our answer choices, I can see here that, and I need to put let me bring that up there. There we go. We can see that all the answer choices are in terms of D equals something. Now, sometimes on harder problems, they're going to be mixed around. So you want to, if we're looking for something that represents the remaining distance, then likely you're going to want D equals something. That's not always the case, not 100% of the time, but that's usually the case. Now, as I look, how do I know when to use the formula? The y equals mx plus b formula. How do I know? Well, in this particular case, I can look at the answers and I can see that they're all in that form. D equals 2n minus 800. So I've got my y here. I've got my m here. I've got my x here. And I've got my b here. Y equals mx plus b. It's already in that form for me. Okay. Now, even though the rest of these are not in the same order necessarily, here I have b before I have mx. Okay. But they're still both there. The elements are still there. They're just turned around. That's the only difference. Okay. So, oops, didn't mean to do that. Let's see, there we go. All right, so I can look at the answer choices here, and that tells me what kind of formula I can use. But sometimes, again, the answers are not going to be, you might have some different variety in the answer choices, and they may be arranged differently. So that might not tell you. But what I do know is that I've got distance here. I've got D equals something. And I'm looking for the distance in miles that Celia will ride to have, Celia will have to ride to finish the event after riding for N days. Okay, so we have a remaining distance. That sounds like a Y. Okay. Remaining distance, what remains, that's our resulting value. After a certain number of days, that's going to be a unit. Okay. So our N here is basically like X. All right. Now let's go back to the beginning of the actual question. If she plans to ride 20 miles per day, 20 miles per day, that's a rate. So we've got this distance is going to be in miles. Okay. This N here is going to be in days. Our rate here is 20 miles per day. So that's 20 miles per day. Okay. So we can cross out the days here. And then we go back to the beginning of the prompt. In a training event, Celia must bicycle 800 miles to reach the finish line. If she plans to ride 20 miles per day, what's the remaining distance? So our 800 is what she starts with. That's her goal. That's how many miles she has to start to begin with. So that's going to be our B. Okay. So y equals mx plus b, y equals, or d, sorry, equals 20n plus 800, except that we are subtracting this number from the 800 in order to get this. So that means that this needs to be negative 20n plus 800. So we look up here and we find that that is B. Okay, now the numbers are turned around, but it's the same numbers. It's the correct numbers. So there it is. Now, if you're looking for a shortcut to solving these, one of the shortcuts is to look at the answer choices and see what's different. So in the answer choices, I see that I have 800 appears twice, both in B and in C. Okay. I see that, and I've got a negative 800 here, but that's different. Okay, 800 by positive 800 appears twice. I noticed that my slope value, my m, here is 20. Here it's negative 20. Here it's positive 20, and here it's actually 800. So the slope varies from 20 to negative 20. Okay, so I could either start with the slope or I could start with the distance, but I can see that since I go back to the beginning of the problem, if she plans to ride 20 miles per day, so immediately I'm looking at that as I'm subtracting that number from my D, which is the remaining amount. So I'm going to look for a negative slope, and my only answer that has a negative slope is a negative slope of 20, by the way, or slope of negative 20, I should say. B is negative 20, so there's my answer. I can jump right on it. Or if I notice that if I wanted to do the initial value approach, I could see that I'm starting with 800. Okay, so if I'm starting with 800, then I'm looking for an 800 in my answer choices. And I see that I'd say B has positive 800 and C has a positive 800. So I can cross out A and D. I've narrowed it down to those two. And now I want to look at the slope to get the answer. So that's a shortcut. That's a shortcut for that particular problem. Okay, next example, we're going to take a look at this particular one with the tables. Again, start with the question: which one of the following equations shows a possible relationship between X and Y? Now, one of the tricks to the SAT in terms of maximizing your time, if this is one of the first 5 or 6 questions, and sometimes even beyond that, in the non-calculator section, or one of the first 11 or 12 questions, we often don't have to read the entire prompt because it's often telling us the same thing that we already know. The table above shows some values of X and Y and their corresponding values of Y. So we've read the question. Do we really need to read the prompt above? We do need to read the question just to make sure that we are going to be answering the right thing. And then we drop down immediately to the answer choices to look at what the answer choices tell us. Now, in this video, starting with this segment, I want to ask questions to you guys and have you guys answer on your own. Obviously, I'm not going to hear your answer, but you're going to need to stop the video yourself. I'm not going to take time to pause in the middle for your answers. So my first question to you is, what do all these answer choices have in common? Well, they're all linear equations. More specifically, they are linear equations in the form of y equals mx plus b already. So I have a slope choice of either 1, -2, or 2. I have a y-intercept choice of either 5, 8, or -4. Okay, so that should kind of guide where I go from there. Now, let's talk about really quickly what y-intercept and slope mean in terms of a graph. So in any line that is not vertical, what is the y-intercept? Well, it's the point at which the line is intercepted by the y-axis here. More correctly, it's the y-coordinate of the point at which the line is intercepted or intersects this axis. So in other words, right here is where I'm looking for my y-intercept. Now, what will be the x-coordinate on every y-intercept? In other words, on any point at the y-axis, what is my x-coordinate? It will be 0, because I'm just starting at the origin and going straight up or straight down. So, and then the y-intercept is going to be whatever that y is, however high I have to go or low I have to go. Now, let's look at this way. I've got y equals mx plus b. I have a value of 0 for x. And when I multiply m times 0, I'm going to get 0, which means that my y is simply going to equal b at that point. Y equals b when x is 0. Okay, so y-intercept is a y-coordinate, where 0 is my x coordinate. Okay, all right, that's important, because as we look at the problem here, and as we look at the, sorry about that, as we look at the table, we can immediately go to the table and say, where is 0x? It's right here. That means that this is going to be my y-intercept. So A and C are eliminated as a result, because these two are the only ones that have 8 as a y-intercept. Now I want to find my slope. What's the formula for slope? Rise over run, which is my difference in my y's over my difference in my x's. In other words, I choose any point and I make that the second point, and I choose any other point and I make that the first point, and I subtract the y coordinates from the corresponding y coordinate, other y coordinate, and then the corresponding x from the corresponding x coordinates. So now which should I choose? Well, since I have 0 here, that makes it easy to go from 1 to 0, and it makes it very easy, which means that I'm going to have I could do this in my head, but I'm still going to write it out here for you. 1 minus 0, we know that's going to equal 1, and then on the top we've got the corresponding y, which is 10, and the corresponding y here, which is 8. So that's going to give us 8. That's going to give us 2. I'll write it down here. Sorry, guys. That's going to give us 2 over 1, or a slope of 2. So now I go back to my 2 remaining equations and I find that slope of 2 in here. And there's my answer. So I could have started with the slope. And if I had started looking for the slope, I would have immediately eliminated A, B, and C. and seeing that D is my only answer choice. However, I started with the y-intercept because there's no arithmetic to do in this case. All I had, now there's not much to do with the slope, but I could do this. I don't have to do anything in my head. I just look at it and say, okay, well, I'm looking for a 0 in the x of the x's, and I find that there's my 0 and there is my y-intercept 8. So that quickly allows me to eliminate 2 of the answer choices and then go with the slope to find my final answer. Okay, so that's how you do it. And that's how you can use a couple shortcuts to get through that question very, very quickly. Okay, let's look at another application of y equals mx plus b. In this particular case, we have one long question. Which of the following is an equation of the line? Equation of the line. And if we look at the answer choices, they are all in the y equals mx plus b format already. In the xy plane that contains the points 1, 8, and 5, 16. Now, what do we notice about the differences in these answer choices? They all have a different slope, but there are like y-intercepts here. So rather than look for the y-intercept, I'm going to look for my slope. And because I'm given 2 points, that's going to be easier to find anyway. So that's all I need to do is find the slope, and I've answered the question. So m equals, and this is going to be easy, I can tell, 16. Here's my 0.2, and here's my 0.1. So there is coordinate 2, which is 16, minus coordinate 1, which is 8. Coordinate 2 again, corresponding coordinate 5 minus coordinate 1, which is 1. So 8/4 gives me a slope of 2. So my answer choice then is B, the only possibility. And that's it. That one, pretty straightforward. Find the slope and you have found your answer. All right, in the fourth example here, we have a table, as you can see, with speeds and pulses. And we have a question here. Which of the following equations describes f of x? Okay, what is f of x? Well, f of x, for practical purposes, is a function which we will call y for our purposes, okay? And functions can be lines, they can be parabolas, they can be sine waves, it could be all kinds of things like that. So, and usually they move horizontally across a graph. So we're looking at y, and we're still looking at y equals mx plus b, as you can see from all the examples in our answer choices. So still the same thing. Don't let the f of x freak you out. Okay. Now we need to know what, presumably, which equation is going to match up with this table. So the table lists values. Again, this is one of these things where we probably don't need to read the rest of the prompt. We could probably just do it from here, but just to be on the safe side, the table lists selected values of June's jogging speed in miles per hour, speed miles per hour, and her corresponding pulse in beats per minute. Wait a minute, Terry, I thought you said that rates like miles per hour and beats per minute were going to be your slope, that the slope represented rates and rate of change. Well, in this particular case, that's not going to happen, because these are different values that are being given for miles per hour and different values that are given for beats per minute. In other words, what M and B ultimately have to be our constants. In other words, it's one number, it's a single number that works for this equation. So when you have multiple rates, then that's not going to be the M or the B. That's going to be the X and the Y. Okay. And there's a linear relationship between June's speed X and her pulse. So that means there is a linear relationship between the X and the Y. This is not a parabola. It's not a sine wave. It is a line, and X directly affects Y. Again, that is your independent variable affecting your dependent variable. So, and it's f of X is basically Y in this case. Okay, so we look at the answer choices and we notice that we have 89, 89, 65, 62, 3 different Y intercepts, 2, 5, and 6, 3 different slopes. Well, let's look for the slope first. I think that's going to be the best way to go. In this case, we're trying to create this equation. So we need to go for the slope. Let's go with, let's see the difference in these two values. So we've got 90 over 80, minus 80, sorry. And then the corresponding 5 over 3. Okay, so that's going to give me 10 over 2. Or a slope of 5. So get rid of A, get rid of D, and now we just have to test out these equations. So there's a couple ways I can do this. Of course, I can plug in my slope into this equation and plug in my numbers. That's probably actually the easiest way. So let's just take 3 and 80 as our X and Y values. So I've got 80 for my Y, and I've got a slope of 5 and an X value of 3. And we've got B. So what's happening here is I've got 80 is equal to 15. What I'm going to have here, the only one that's going to work is 65. So that is my answer. 65 and 65, and my answer is B. Nothing to it. Let's take a look at this one, which is a little different in that it does not actually involve the equation y equals mx plus b, but rather the principle of it, or part of it. In the xy plane, what is the coordinate, the y coordinate of the y-intercept of the graph of the equation y equals this? So we initially we look at it as some hairy, awful thing, but let's realize what y equals mx plus b means, what y-intercept means. Y-intercept means that 0 here is going to be x, our value for x, so that y equals b. And therefore, if we're looking for the y-intercept, we want to set this y equals 2x plus b with the x equal to 0, regardless of if there's a plus or minus or anything after this. So y-intercept simply means that it is the space, or that is the y coordinate whenever x is 0. That's what it means. It means the y coordinate whenever x equals 0. So when we see y-intercept, that means we should be thinking set x equal to 0. If we see x-intercept, same thing, set y equal to 0. Okay, we should be thinking that. So let's set this equal to 0. Sorry, I don't know why I put that should be 0 there. So we have on top, 2, we have 0 minus 12, which is negative 12. And on the bottom, we have 3 minus 0, which is 3. And that gives us a y-intercept of negative 4. So our answer is negative 4. That's it. That's all there is to it. Now, notice how they try to trick you. If I were to put 3 in for x, I would get 3 minus x equals 0. Well, you don't want that anyway, a 0 as a denominator. If I had 4 here, I would have 8 minus 12, which is negative 4, over 3 minus 4, which is negative 1. So that's positive 4. 6 here would be, make this 12 minus 12, which is 0, a numerator of 0, which means the whole thing is 0. So these are the different ways, particularly with D, that they try to trick you to put the wrong answer. But just remember, y-intercept means x equals 0, and that's what we need to put in there to find our answer choice. Okay, this one is a little bit different also. It's one that often confuses a lot of people when actually the answer is really simple, as is the case with a lot of these SAT questions. So we start, as we do with all our other questions, with the question itself. We find, where is the actual question? Here it is. How many inches per year has George grown since he was 2? Inches per year. That sounds like what? A rate. Inches per year. Okay, sounds like a rate. So that could very well be our slope. Now, if we go up to the top, we see there's an equation here. And we see, we really want to know exactly what these other things mean before we answer. So let's back it up to the beginning of the question, where it says, if the equation above represents George's height, okay, that's height, and y represents the number of years. Okay, so remember that when I'm looking at mx and m is a rate, then what I'm going to have is something like this. I'm going to have this times some number for the value over something. This is the rate, and then that has to multiply out, so that here I have the number of years I'm going to put in here, y, as it says, number of years. So then that's going to multiply out, cancel out, and my answer is going to be h. H is in inches, so that's going to be something in inches, and yeah, that works right there to cancel it out. So therefore, in fact, this is going to be my rate. That is my rate. That is my inches per year, the number 3. I don't have to go any further, so the answer is 3. That's it. There's other information here that's a distraction. George has grown at a constant rate from the time he was 2 years old, when he was 39 inches tall. Okay, there's our starting point. He was 39 when he started growing in our equation, in our timeline here. He is now 6 years old. So this here is a red herring, meaning this is distracting information. We don't need that. That information is a distraction. And 39 inches, well, that balances out. I mean, that finishes out the equation, but it's also not necessary in order to answer the question, which is that the rate of change, which is the increase per year, is 3. And that's it. So that's what you're looking for. Okay, we finally have a question here with a graph. Fantastic. So where do we start? That's right. Which equation defines f? And we look at our answer choices, and they are all, what do they all have in common? They are in the form y equals mx plus b. And what do we notice about these answer choices? Well, the y-intercept is either 3 or -3, and the slope is either -2/3 or -3/2. So the easier things that would help us to identify which which answer it is, are not there. We're going to have to do, because the slope, we can tell by the line that the slope is negative. Well, these are all negative, and we're going to have to find both the y-intercept. What should we start with? The y-intercept. Okay, y. Okay, if we notice that it's just where the line hits the y-axis, so it's easy, no calculations needed. And so we come over here and we see that our y-intercept is going to be 3. So we can eliminate B and D. Now we look for our slope. Okay, we had our B, now we want our M. And our slope is going to be negative rise over run. And so that's going to be a -1, 2, 3. And right there, that's really enough to let us know that the answer is C. But let's go ahead for kicks, solve it. And our run is going to be 2. So -3/2, and our answer is C. That's all there is to it. All right, let's take a look at this equation, also a function. And the question is, which equation defines f? What do we notice about the answer choices? They are all in the form y equals mx plus b, again, where y is going to be f of x. So for the linear function f of 8 equals 1. Okay, so let's say this basically means that f of x or y equals 1 when x equals 8. That's all this means. Okay, so we've got the same slope for all of these, which is 1/2. Now we just need to find our b. So let's create the function here. 8 is our x, 1 is our y, our slope is 1/2, and so that is 1 equals 4 plus b, or if we subtract 4 from both sides, then that's going to give us -3 equals b, and so our answer is going to be A. Quick and simple. Now, another way that you could do this is just plug in numbers until you get the right answer. Here's an important tip. Notice that what changes is the y-intercept, the b. So that means it changes, it ascends. It goes from -3 to 7.5 or 15/2 here. So if I'm going to plug in numbers, I'm going to start somewhere in the middle, because then if I know that that number is not correct, if that answer is not correct, I can either go down or up, but I don't have to go down or up as many to get my right answer. So let's start with B. Okay, so I've got 1/2 x. Now this is going to be interesting, because as soon as I plug in the 1/2 x, I'm going to get 4, and that's going to be true for all of these. So I'm going to get 4, and I know that 4 plus 3 does not equal 1. which is what I'm going for here. That's going to be my y that I'm going to plug in here. So I'm going to have to go lower than that. Therefore, using this method, I find that A is the answer as well, because -3 is less than 3. And I know my answer has to be less than 3 because 4 plus 3 gives me a number that is greater than the number I'm looking for y or for f of x, which is 1. So I've got to go down, and therefore I go to answer A. And at this point, I could go ahead and plug it in just to be sure. 4 minus 3 indeed equals 1. And so that works, and we're all happy with that. Okay. But if I'm in a hurry, then I don't necessarily have to plug it in. I just know that by the virtue of the fact that this didn't work, this has to be my answer. Okay. Okay, here's one that looks like it's a statistics question about scatter plots, but it's essentially about y equals mx plus b. We see a graph here or chart, and it says, what does the line of best fit predict about the increase in the percentage of car owning households over the 70-year period? We see a scatter plot and a line of best fit. Okay, and if we read this, we see the scatter plot above shows the percentage of households with cars every 10 years between 1910 and 1980. Okay, so this, I don't see 1910, 1980. Oh, there it is. It says years since 1910, 10 years since 1910. That's a weird way of writing it. But anyway, a line of best fit is shown, and its equation is y equals such and such, so and so. Okay, y equals mx plus b. What does the line of best fit predict about the increase in the percentage of car owning households? And that is what our y-axis is labeled as, over the 70-year period from 1910 through 1980. Yeah, it stops at 70 years after 1910. Okay, this is actually very easy. There's a lot of extra stuff on here and things to make you think about this or the other. But essentially, all four of the answer choices are saying each year between 1910 and 1980, or every 10 years between 1910 and 1980, the average percentage increase was blank. Okay, so we know that the percent increase is going to be the rate, the rate of change, which is our slope right here. And that means that our answer is going to have that in it. So we can look at A, and we can look at C and eliminate B and D. And it's asking, and this is over the period of, its equation is y equals, this is the period over per year. This is a rate of change per year. Now, it doesn't matter how many years, what increments are used on the our chart here. This could be done over a period of, let's say, 10 years. It could be done over a period of 20 years. I could make this smaller. See, there goes over 20 years, over 50 years, over, whatever I want to do. That's not going to change the fact that the equation is per year, is a yearly increase every year, every year. So my answer is going to be A. Okay. So when we're looking at a rate of increase, it's going to be on a yearly basis, unless it says otherwise, if we're talking about years here. All right. Okay, I like this one because it looks like a statistics question or a question about scatter plots, but essentially it's a y equals mx plus b question. Now it helps to know a little bit about scatter plots, but you don't really have to. You can still just look at the graph and see what's going on here. And first, let's start with the question. What does the line of best fit? Okay, if I don't know what that is, I can just look at that and see a line there that kind of fits among these dots. What does the line of best fit predict about the increase in the percentage of car owning households over the 70-year period? Okay, so let's look at what those two data bits mean. The increase in the percentage of car owning households. Is that on any axis? Yes, it is. Percentage of households with cars. There we go. Over the 70-year period. What 70-year period? Let's see. It starts at 0 and then goes to 70 years, and there's no more data after that. So if we go back to the question, so let's look at the answer choices actually first. And we see that each year between 1910 and 1980, the average percentage increase, okay, that's this percentage of increase was a certain amount. And then this says basically the same thing, except the amount's different. This says every 10 years, and then the amount's the same as this amount. This says every 10 years, and then this amount is the same as this amount. So this is saying the average percent increase. What is the average percent increase? What kind of number is that? If I'm looking at my equation here, which is obviously a y equals mx plus b equation, well, the rate of increase is going to be, or percentage increase is going to be this right here, the average, the rate, my m. Okay, so in other words, I'm looking for this number right here, and that means I'm looking for the answer choices that have it, which are A and which are C. Now the difference in these two is that A talks about each year, this talks about every 10 years. Well, the graph shows every 10 years. That doesn't matter. Because what I see is that the plots where the data points come are representative of of a single year, not of 10 years. But even if these dots weren't on there, I know that I can increase the size of this graph in a way, for instance, that shows every 20 years, every 50 years. That doesn't mean that that's going to be my answer, that's how this is being measured. It's being measured yearly, unless it tells me otherwise somehow in this graph. And it doesn't. Just because the increments are every 10 years doesn't mean it's being measured every 10 years. So A is my answer. And that's it. Simple enough. Okay, our last problem here is going to be a grid-in or free response question. And it's very similar to one that appeared last on a recent test. So presumably it's a tough one, but we'll see about that. By the way, you should know that the grid-ins are generally easier than the hardest multiple choice questions. So the last question on either the non-calculator or calculator test should not be as hard as the last multiple choice question. The difference is you don't have answer choices, so you have to know what you're doing, but it really shouldn't be that difficult. So let's take a look at this question. What is the value of B? Okay, and I noticed this equation caught my eye, so presumably B is the y-intercept, but I'm going to read it all just to be sure, especially on the last question. I want to read as much as I know I need to. If line S is perpendicular to the line, okay, perpendicular to the line, that tells me something right there. It's perpendicular to the line with equation y equals negative 4x plus 16, what's the value of b? And this equation we notice is in y-intercept form. So what does perpendicular tell us? Well, it tells us that the slope of the line we're looking at is going to be the opposite reciprocal of the other line. So if our slope is negative 4, then the slope of S is going to be the opposite reciprocal, which is a positive 1/4. Okay, now let's go back to the beginning in the XY plane, line S, back to line S again, with equation y equals mx plus b, where m and b are constants, passes through the point 9, -2. We're looking for b. We want b. We have a point. So when we don't know exactly what to do, let's just see what everything is. We have a point, which is 9, -2. We know that that's an x. We know that that's a y. We know that we have our slope, which is this right here. All we need to do is plug those in to get our b. So let's do that. And 9 equals -1/2 plus b. Oh, wait a minute, I'm sorry. That's our x coordinate. So x has to be here. Okay. Glad I caught myself there. I do, even the best of us make mistakes here. So I could edit this out, but I want you to realize that we all do make mistakes, and we need to be very careful about those things. So y is -2. M is 1/4. X is 9, and then b. So -2 equals 9/4 plus b. Let's subtract 9/4 from both sides. Okay. And I want to turn that into fourths. So we have a common denominator here. So that's going to be -8/4. And so I'm going to have -8/4 minus a minus. Okay, equals b. So 8/4 plus positive 9/4 is going to give me a difference of 1/4. And 1/4 equals b. Now you want to watch your signs and you want to be careful of that. But one good thing about the grid ends is that your answer has to be positive. You can't have negative grid end answers. So our answer here is 1/4. And that's how you would want to write it in the grid end section 1/4. And it doesn't matter if it's space 1/4 or if it's 1/4 space. That really doesn't matter. Okay, so that pretty much covers all the different kinds, not all the different kinds, not every single possibility, but that's almost every possibility of a slope intercept type question that you're going to have. All right, and hopefully I've given you some tricks to get to the answer quickly, so that you're in some cases not having to write out the entire formula. And I wrote out things on all of these so that you can see what I'm doing, but you can come up with some shortcuts of your own as long as you practice them, as long as you test, as long as you check them, and as long as you're not making mistakes in practice. Okay, so wish you guys the best, and stay tuned for the next video.